Thank you. Thank you so much for joining this lesson. We're going to look at mathematics paper 1.
Thank you so much for joining this.
Section 2 paper. Section 2. We've already started the discussion of this paper. The section 1 has already been fully covered. Yeah, those who have been following the platform, they know very well that the section 1 of this paper has fully been covered. And now we are supposed to adjust to section 2 of the same, whereby you are supposed to choose your best 50 marks. Remember, we're going to do all the marks so that you may see that everything is doable. There is no question that cannot be done. But now, from there, you'll be able now to choose. You'll be able to choose what is best for you. So thank you so much for joining us. Please remember to subscribe. Those who are new to the platform, remember also to share the link with your friends. We are starting when we are 12, but by the time we are starting, we can be 12 times 10. Everybody can invite their friends and all shall be well. Number 17, which is our first question in this section. Water flows through a cylindrical pipe of diameter 4.2 centimeters at the rate of 50 meters for every minute. Look at that, 50 meters for every minute. Calculate the capacity in liters of water delivered by the pipe in 1 minute. Take pi as 22 out of 7. This is on rates of work. I want to illustrate what is happening here. We are having a pipe, then this pipe is cylindrical, and within the pipe, water flows through 50 meters in every minute. Through 50 meters means because of this other dimension, which is in centimeters, we can also make this one centimeters, which is 5,000 centimeters. Is that okay? And we can now compute the cross-section area, meaning that the volume of water that will flow in a minute can be computed. So volume is usually given by cross-section area times length. Cross-section being cylindrical, it's a circular. So we talk about pi radius, which is 2.1 squared times the length. So the water shall move through a length of 5,000 centimeters. So this will give us the volume in cubic centimeters, 22/7 multiplied by 2.1 squared multiplied by 5,000. This is going to be 69,300 cubic centimeters. Then something else that we know is that for every 1 liter, there is 1,000 cubic centimeters, meaning that for us to get now this volume converted to liters, we divide by 1,000. When you divide by 1,000, this is giving me 69.3 liters. So I had to divide the volume by 1,000 to get capacity. So that is now the capacity of water delivered by the pipe in 1 minute. We are together there. Type here some learning. Then remember to share with a friend. Remember to invite a friend to this platform. Let us learn together. Today, the broadcast is very clear. You can see, yeah, all is well from this side. I hope you're also getting us clearly. Part B of the same question. We told that a cylindrical storage tank of depth 3 meters is filled by water from this pipe at the same rate of flow. Okay. Now, water begins flowing into the tank at 6:30 p.m. and is full by 11:30 p.m. the same day. Calculate the cross-section area of the tank. in meters squared. Now, what you need to understand here is that already we can find the time taken to fill this tank. Time taken to fill the tank. Time taken shall be all the way to 11:30 from 6:30. How many hours are this? How many hours are this? This is going to be 0, 0. I'm subtracting it. Then 5. So we have 5 hours. 5 hours is equivalent to 5 times 60. So that you may get time taken in minutes. So now, to fill this tank, it takes 300 minutes. And we know the volume that enters the tank. We know the volume that enters the tank in a minute. So within the 300 minutes, and this pipe has been delivering water within all those limits, then what is the capacity of this tank? So we say in 1 minute, the pipe is able to deliver 69.3 liters. What about within 300 minutes? If in a minute, it delivers 69.3, what about in 300 minutes? So this shall be 300 multiplied by 69.3. So we can get now the capacity in liters. We multiply by 300 minutes. Therefore, it's 20,790 liters. This is now the capacity. Yeah, this is the capacity of the tank which is being filled by the pipe. Now that you have the capacity, can we find volume? Volume in cubic meters, we divide this one by 1,000, simply because we know in every 1 meter cubed, there is 1,000 liters. So 20.79 cubic meters. This is now the volume when the tank is full. Now that we have volume, now that we are having volume, can we talk about cross-section area? Cross-section area, simply because we have the height of the cylindrical tank. This way, volume is given by cross-section area times height. Therefore, the volume of 20.79 equals to the unknown cross-section area times height 3 meters. So the cross-section area can be obtained when we divide this by 3. When you divide by 3 both sides, you get 6.93. 6.93 meters squared. Meters squared. So now we are having the cross-section area of the cylindrical tank. Are we together up to that point? If yes, type yes, I'm learning. And also remember to invite your classmates, your estate mates. Somebody is asking for which grade. This is for Form 3s and Form 4s. Form 3s and Form 4s. Thank you, Sironga. Form 3s and Form 4s. Grade 10 work has already been uploaded today, so you can check. Grade 9 work, 7 work, and 8 work has been uploaded almost frequently. We have videos for those classes, so kindly check content for your level. But you're invited. You can still check mathematics here. Mathematics can be learned universally. So just keep following us. Look at part C of the same question. A school consumes the capacity of this tank in 1 month. Water costs 250 Kenya shillings per every 1,000 liters and a fixed basic charge of 27.60 per month. Calculate the school's bill for water in 1 month. The school's bill for water in 1 month. So we're being told that for every 250, for every 1,000 liters, in other words, it's 250 Kenya shillings per cubic meter volume. because we're being told in every 1,000 liters, and 1,000 liters equals to a cubic meter volume. What about this tank? What will it cost? The volume is here, 20.79. So if 250 shillings is for every 1 meter cubed, then what will be the charge for 20.79? Are we together at that interpretation? Are we together at this interpretation? 20.79 times 250 times 250. Computing this, I'm getting 5197.5 Kenya shillings, or 50 cents Kenya shillings. Then there's another fixed basic charge. This one maybe is for repair of pipes and all that. 2760 must also be spent. Therefore, the total expenditure on water shall be exactly 2760, the fixed charge, then the water bill in a particular month, 5197.50. So this then shall give us a total of, I'm adding 2760. This is exactly 7957. 7957.50. So this is now the total amount of money this particular school will have to pay per month. That is the amount the school will pay per month. Thank you, St. Peter's Conim. Thank you. Continue following us. Now we can check number 18. And for the Form 3s that are following us, together with grade 10s, together with junior school, together with primary school, we're going to have one-on-one classes for the December holiday. To book your chance, 070415 3366. So reach out to us. Yeah. So that you may book yourself a chance, so that you may interact with us. The classes are via Google Meet, and they're usually very constructive. So we can check number 18 together. 18 can be checked now. We're being told in number 18 that on the grid provided, draw the triangle PQR in which P23, Q12, R41 on the same axis. Draw the second image such that P double prime is -23, -1, 2, and R is -41. Can we draw the two? Can we draw the two triangles? So the first one, P, which is a 2, 3. This is the coordinate. That will be P. Q is 1, 2. 1, 2. That is Q. Then R is going to be 4, 1. 4, 1 is here. 4, 1, yeah. So that's going to be R. So we can now join. Thank you, Kajiado County. We can now join PQR. Okay. PQ, then to R. Then R. R like that. Yeah, so we are having the first triangle. We can check the second one. We are already having the coordinates. The coordinates are -2, 3. -2 is here and 3 is here. So that's our P double prime. -1, 2. -1, 2 is here. So Q double prime, and finally -4, 1. -4, 1. It's here. This is now R double prime. Then we can connect now to come up with the triangle. We can connect to come up with the triangle. like that. Okay, so you see, very good. The two triangles now. Everybody can see the two triangles. Everybody can see the two triangles. We are together there. Thank you. Let's continue sharing. Let's continue sharing. So we have plotted. Imagine just interpreting coordinates. Just interpreting coordinates, and we are at 2 marks. The first 2 marks like that. The first 2 marks like that. Now we check part B. We check part B. Part B of the question is telling us that on the same axis, draw P prime, Q prime, R prime, the image of the first triangle, and a reflection in the line y plus x equals to 0. Now, you know very well that we cannot reflect unless we first understand the mirror line and we draw it. If y plus x equals to 0, can we see that y then equals to negative x? Then if that is so, why don't we have a small table, x and y? When x is 0, 0 times negative will give us 0. When x is 1, y should be negative 1. When x is 2, y should be negative 2. Like the value of y is the negative value of x. You get that? Okay. Then it means the line passes through this point. So if, okay, 0 is there first. So 1, negative 1. 2, negative 2. 3, negative 3. 3, negative 3, like that. So with this, we can do a straight line which will serve as our mirror line now. Line y equals to negative x. Line y equals to negative x. So let me do that straight line. The straight line is here. Now we are supposed to reflect now along this mirror line. Y plus x equals to 0. Y plus x equals to 0. Now to reflect means you join every point to the mirror line perpendicularly. Then you proceed to the opposite side an equal distance. For example, we can start with Q. It's my nearest coordinates. So I join, let me use a black there. I join Q to the mirror line. I join Q to the mirror line like that. Then I move an equal distance to the opposite side. Equal distance to the opposite side, such that from the mirror line to Q, now from the mirror line again, along the same line, Q prime shall be at an equal distance. So this will be Q prime like that. Q prime like that. How will I identify P? I do the same. I join P to the mirror line, then I move an equal distance on the other side. So from the mirror line to where P is, now I'm supposed to move again an equal distance, and P prime shall exactly be at such a point. I proceed, I do the same for R. I do the same for R. So I join R perpendicularly to the mirror line. Then now I move an equal distance to the other side. So from the mirror line to where R is, then now to the opposite side, and I do so an equal distance. So this is supposed to be R prime, like that. Then with this now we can join to come up with the triangle. Allow me use this color. Colors are many here. I don't even know the names of the colors, but we are going to enjoy the many colors. Okay, so that our work is very decent to also avoid monotony of a specific color. You see now? You see now? We have reflected the first triangle to the first image. Remember, there is this second image which we just plotted. So we can continue reading instructions and see what we are supposed to do with such. Now, we're being told this, describe fully a single transformation that maps triangle P prime, Q prime, R prime onto P double prime, Q double prime, R double prime. Okay, so what transformation maps the first image to the second one? The first image to the second one. So the first thing that you're supposed to do is to join, because you can see the figures are congruent. So it's not an enlargement. It is not an enlargement. It is not a translation because the shapes are not directly, okay, they might be congruent directly, but now when you raise Q to Q here, by the time it's fitting at Q, P is not at P, R is not at R. And for that reason, we can start thinking of a rotation now, whereby we're supposed to connect this way, a point and its image. If it's Q, for instance, we join Q to Q prime like that. Then we bisect. We bisect this particular line. We bisect it. Yeah. So we bisect Q prime. Let me use this. We bisect Q prime. Bisect Q prime. Like that. Can we also join P to P prime? We join P to P prime. P to P prime, we join. P to P prime, we've joined. Then after that we can bisect. We can bisect P to P prime. We can bisect. Let me use this one. This. Now, the two bisectors are meeting at some point. Where they meet becomes the center of the rotation. So this particular transformation is a rotation center 0, 0. Then now we identify the angle of rotation. For us to identify the angle of rotation, allow me get back to red, so that I connect Q to Q prime. No, Q to the center of the rotation, then again to Q prime. Like that. Q to the center, then to Q prime, meaning that we can now identify this angle, which is 90. Then now the direction. Now from this point, we are moving in the clockwise direction. So 90 in the clockwise direction, or you can say positive quarter turn. Actually, the single transformation can be described using one word, a negative, sorry, because it's clockwise. A negative quarter turn. A negative quarter turn about 0.00. A negative quarter turn about 0.00. That's simple. Quarter turn about 0.00. Beta School, thank you so much. And Kiambu, Asante. Let's continue learning. Please invite your friends from those great places that you come from. Continue inviting your good friends. If you have some good friends, kindly invite them. Then now we check part D of this particular presentation. Part D says that we draw the third image such that it can be mapped Now look at that instruction. Look at that particular instruction. Such that it can be mapped. Such that it can be mapped onto the first by a rotation of positive 90 about the origin. By a positive 90 about the origin. Now, if this third one can be mapped onto the first one through positive 90, then it means the first one, look at this, P triple prime can be mapped onto P using positive 90. Then it means to reverse the particular transformation, now that we have P, for us to map it to P triple prime, then we should use about the same center, about the same center. We rotate in the reverse direction now. We use negative 90 now. So we are going to use negative 90. I want us to be in agreement there. We're going to use negative 90 about the origin so that we get the third image. So we join P to the center, then negative 90 means clockwise. P to the center, we can start with P. P to the center. Then now we turn through 90. P to the center, then we measure 90. Yeah, allow me measure 90 at that point. Then I produce that line. Look at that. I produce that line. Then now I'm supposed to move an equal distance after turning 90 in the clockwise. I move an equal distance. I move now an equal distance along the angle that I've measured to a point like this. This will be my P triple prime, like that. P triple prime. Then I do the same for Q and R. Doing the same for Q and R means Q, I join it to the center. I join Q to the center. Then I measure 90 in the clockwise direction. 90 in the clockwise direction. Then I produce the line. And I move an equal distance. I'm supposed to move an equal distance. So I shall find myself at a point here that is Q triple prime. Then now I have to look for R triple prime. So I'm joining R to the center, R to the center. Then I move through 90 in the clockwise direction. In the clockwise direction. In the clockwise direction, like that. Then now I check an equal number, an equal distance. I'm supposed to check my accuracy on the 90 degrees measurement. There. At a point like this one, I can now have that was R triple prime. R triple prime. Then now I can come up with my triangle. P, Q, R. Like that. Exactly like that. the green one. Then at this point now, look at this. State the type of congruence between the first and the third image. The first and the third image. The type of congruence. Now, for the type of congruence between the first and the third, we are supposed to identify the transformation first. The transformation that would map this one onto this particular onto this, and you discover that it is a reflection along the y-axis. When you reflect Q to the y-axis and you move it to the other side, and you do the same for P to the mirror line y-axis, you move it to the opposite side, then R the same. So this is a reflection. Now that it is a reflection, then we talk about opposite congruence. Opposite or indirect congruence. Since it is a what? A reflection. You're supposed to know that indirect congruence, for indirect congruence, it is a reflection. A reflection is responsible for the transformation. Is that okay? Then for a direct congruence, a rotation and a translation. A rotation and a translation. Those are your notes. Indirect congruence is brought about by reflection. Direct congruence can be brought about by either rotation or translation. Are we together in that? Please confirm. Please confirm whether we are together in that. Confirm whether we are together in that. You can use the comment section. Watching from Nairobi, Nyambururu Girls, Kakamega Mumias, Kiriani High, watching from Nairobi. Thank you, thank you, thank you, thank you, thank you, thank you. Somebody is telling me that, teacher, during such transformation, are you able to use simple formula without all this construction? Why are you using simple formula when I'm teaching you how to rotate, how to reflect? Why are people after shortcuts, ladies and gentlemen? It's a simple question I'm posing to you. Why don't you embrace the correct methods and how things are supposed to be done? Like to reflect. It's like a practical in math. When you are rotating, you perform a rotation. Why should you think that there is a formula? Because if you want a formula, there are funny formulas that you can find them, yes, but will they earn you marks? You are supposed to show that you are rotating. You are supposed to show that you are reflecting. Kindly avoid the appetite of shortcuts. The appetite to any shortcut should be killed. Kill any appetite to a shortcut because it's going to mess you up. Together, at that point, appetite to shortcuts shall mess you up. So thank you for the question. I hope I'm answering now the whole class that any shortcut, appetite to shortcuts should be killed. Say no to any appetite to a shortcut. Number 19, which has a part A. Two trains. Look at that. Two trains, A and B, are such that they are 40 meters long and 160 meters long, respectively. Now, their speeds are 60 kilometers per hour and 40 kilometers per hour, respectively. The two trains are 100 meters apart and moving towards the same direction in a pair of parallel tracks. Okay? Calculate the time in seconds it takes train A to completely overtake train B. Now look at this. Look at this. I want to draw one train, another train, the distance between them. We're being told that there is 100 meters between them. They are 100 meters apart. Then we are having train, okay, train A, 40 meters long. Train B, 160 meters long. Like that, So, for train A to completely overtake train B, what distance is it supposed to take? It is supposed to cover the 100 between them, the 160 distance of B, then again, a distance equal to itself so that it may completely overtake. Thank you from Capsabet. So that it may completely overtake now, we have to talk about the total distance it shall cover. So train A is supposed to cover all this distance, 40 plus 100, that's 140, plus 160, we get 300 meters. So there's a distance of 300 meters that is supposed to be covered by train A to completely overtake. Underline the word completely overtake train B, completely overtaking of train B. So in a case like this one, then we're supposed to know that the time train A is moving, B is also moving. And for that reason, we start talking about the concept of relative speed. Relative speed for two objects moving in the same direction should be the distance. 60, the difference, that is 20 kilometers per hour. The approaching speed. So A is approaching B at a speed of 20 kilometers per hour, and it has to cover 300, meaning that relative time is given by the relative distance out of the relative speed. This is going to give us 15. This is going to give us 15 hours. Wait. The distance is in kilometers. The speed, okay, the distance is in meters, but the speed is in kilometers per hour. So you can't combine such units. You cannot combine such units. You're supposed to convert either, the distance should be in seconds. So we convert this speed to meters per second. We convert the speed to meters per second. So this speed, 20 kilometers, can be converted by 1,000 out of 1 hour, which can be converted by multiplying by 3600, so that it becomes seconds. So 20,000 out of 3600, we are getting 5 and 5 over 9 meters per second. So that now time is equal to the distance of 300 out of speed, which is now in meters per second, so that the time is directly in seconds. 300 divided by this value, I'm getting exactly 54 seconds. Exactly 54 seconds. So it will take 54 seconds. I've converted the speed into meters per second so that it can work with the distance, which is in meters. Is that okay? Is that okay? Is that okay? Thank you. Thank you. Thank you. I can see people are still inviting their friends. Nyambururu girls, thank you. Kakamega, thank you. Kiriani, thank you. We can see you. We can see you from the studios. Thank you so much. These lessons are made to help you prepare for KCSE. So we are wishing you well, the class of 2026, the class of 2027. Those are the Form 3s. I'm sure they are also following. So we wish everyone success in their academics. Part B of the same question. Now, in part B, we're being told this, that the figure below shows a velocity time graph for a robot in a robotic challenge, all right? So we can see the velocity there in the vertical axis, time in seconds on the other axis. Now we read the question together. If the distance covered by the robot in the first 15 seconds was 180, calculate the value of m. Now, distance covered is usually given by area of the graph. If the graph is velocity time graph, area of the graph gives total distance. So 180 equals to the shape here covered within 15. It's trapezium. So can we talk about half? The two parallel sides are, this side is parallel to this one. This one is 0 to 4. The other one is 0 to m times the perpendicular distance between the two, 15, from 0 to 15. That is the distance between the two parallel sides. Now we can say, can we multiply by 2 both sides so that the half cancels? 360 equals to, we open the brackets by the 15 now, so that we have 60 plus 15m. Yeah, 60 plus 15m. Remember, everything was over 2, but the 2 multiplied 180. So we are having 300 being equal to 15m. To remain with the value of m, 300 should be divided by 15. This is taking us exactly to 20. So the value of m is 20 meters per second, because it's a velocity. 20 meters per second. 20 meters per second, like that. 20 meters per second. Can we check Roman 2 of the same question? Are we together first up to that point? Form 3s, grade 10s, junior school and primary, you are invited to our classes. Use our number here so that you may join our holiday classes. We have classes in the December, November holiday, and we are inviting continuing students to enroll. Grade 9s are enrolling because you'll be preparing them for grade 10. Grade 5s are enrolling. We are preparing them for grade 7. Everybody is just going to join, except the Form 4 candidates who are transitioning to a very different level of education. We are calculating in Roman 2, the deceleration of the particle in the last 15 minutes. Deceleration in the last 15. Last 15 is from 45 all the way to 60. So we can find the gradient. Remember, this was 20. So this is coordinate 20 or 45, 20. Coordinate 45, 20. This is coordinate 60, 0. 60, 0. So we find the gradient. Change in y over change in x. 20 minus 0 out of 45 minus 15. 45 minus 60, sorry. So 20 over negative 15. 20 over negative 15 shall give us what? Negative 1 1/3. Meaning that now this was a negative acceleration. Therefore, the deceleration is 1 and 1/3 meters per second squared. Meters per second squared, like that. Meters per second squared. Roman 3 now. Calculate the distance covered in the last half of the journey. The last half of the journey. We're talking about half of the journey. Okay. The last half of the journey. When you talk about half, you know, half can be in terms of time, in terms of distance. So the distance covered in the last half of the journey. Half of the journey means we can consider the total distance covered divided by 2. So that we talk about half, the last half of the journey. Or we say there is the total time, 60. So what about at 30? What about 30 seconds? So we can talk about these two distances. From 30 to 15 to 45, that is 15. Upwards is 20. So the distance here, in the first case, 20 by 15, 20 by 15, plus, the other one is triangular. The other one is triangular. So triangular, this is a 15 again, from 45 to 60, and vertically 20. So 15 by 20. So when we consider time, it shall be 20 by 15, which is a 300, plus 150, which is 450 meters. 450 meters. That is the last half of the journey. The last half of the journey. Then now we can check number 20. Number 20 from statistics. Remember, I've been telling you that statistics have been there. Statistics has been there. Statistics will be there. And statistics will never fail to be evaluated in any serious examination. So we better stay prepared. Austin from Truvine. Okay, thank you. Thank you, Austin. You can invite your friends from Truvine. When you mention your school, you get the privilege of your school being mentioned in a platform like this one. Yeah. When you mention your name on the comment section, then you have the privilege of your name being mentioned in a platform like this. So you can do a comment. We get to know you people. Otherwise, thank you. Comment on the sound. Comment on the clarity of the video. I can see everything is clear from this particular end. You can see everything is very clear. Natalia from Unity Comprehensive. Thank you so much. Now we can get to the question. Let us flow together in the statistics question. Let us flow together in this one. Now we're being told, using the data above, complete the frequency distribution table below. So they have come up with the distribution table for us. The data below is marks scored by 45 students in a mathematics test. So I want to introduce something else here according to what they have given us. You know, this is a frequency. So you can allow me affect their table kidogo. I talk about tallying column. Then now we have our frequency now computed on a different column. Yeah, this table should be manipulated as much as we can. So we'll be talking about frequency at this point now. But we start with a tallying column. Start with a tallying column. You don't have to exit the meeting. You don't have to exit the meeting. Please continue following. Okay. Now at this point, when we talk about tallying, this is what you're going to do. Look at this. I'm going to use a conspicuous color like this one so that I transfer every value to the class that it belongs. When we start with 32, for example, we place a stick in the class where 32 belongs. One stick like that to represent that value. 81, the class that has 81, one stick. 38, one stick. 84, one stick. 35, one stick. Then we go to 82 here. 74 here. 80, this class. 39 here. 83. Now check, they are already 4. So this one should be used to tie them like that to show that the first 5 you tie like that. First 5 like that. Then we proceed to 79 here. 83, we continue. 81, we are continuing in that class. 42 here. 41 there. 52, 52 here. 65, which class? This one. 43, this one. 80 here. Okay. 84, this class. We go to 41. 41 will belong here. 53, 53 here. 76, this class. 46, this class. 70, 70, this class. 40, that is 40. They are already 4, so we wrap them up. First 5. We go to 43. With 43, we place it here. With the 45, 45, we place it here. What about 71? 71, they are already 4, so we wrap them like that to show the first 5. 50, 50 will be here. They are already 4, so we wrap like that. 46, this class. 50, same class. 70, 70 should be here. 54 should be here. 78 should be here. 80, they are already 4, so we wrap like this. 42, 42, the class is here. What about 51? With 51, the class is here. We have 51 lies. What about 72? 72 should be this class. 53, 5, 3. I can see. Confirm clarity. Sorry. Confirm clarity from that side. Confirm clarity from that side. Proceed to class with 54. 54, this one. Class with 45, same class. 55, the next one. So now we can tally. Now we can do what we call tallying now. These are exactly 5. This is a 7 because it's 5 and 2. Then the next is a 5, 5 and 2. Then we have 3 of them there. 5 and 3, we get 8. 5, 5, we get 10. Like that. 5, 5, we get 10. You can add to confirm. 5 plus 7, we get 12. Plus 12, 24. 27. 27 plus 8, we get 35. Plus 10, we get 45. We had been told that these are marks for 45 students. So we've done it in the right way. We have done it in the right way. That is how it's supposed to be done. Thank you, Kimathi from Kajiado. Thank you, Muranga. Kisau girls, thank you so much. That is Vivian. Natalie, Unity Comprehensive, thank you for following. We can now check something else. We are done with preparing the frequency distribution table. The classes had already been suggested. The classes had already been suggested. So you are not the one to come up with the classes. They had been listed by the examiner. Your work is just to fill in the frequencies now. The tallying column, I established the tallying column so that you may enhance the accuracy, to enhance the accuracy. Now, part B is saying we calculate the mean of the data. Calculate the mean of the data. To find the mean, We will need the midpoints first, then midpoint times every frequency, then we shall be adding now. So I'm going to use my calculator now. I will use my calculator now in the next work now. 30 to 39, we add the two limits and you divide them by 2 so that you may get the midpoint. So the midpoint is 34.5 times f, which is a 5. I'm getting 172.5. The next is supposed to be 40 and 44, and we divide by 2. We get a midpoint of 42. Then by 7, this we get 294. The next is 45 and 54, and we divide by 2. The midpoint is 49.5. Now this should be multiplied by 12 to give us 594. You see that? The next is 55 and 69. Then we divide by 2, a midpoint of 62, times a frequency of 3 to get 186. 70 and 79. And we divide by 2, we're getting 74.5. Then times 8, we get 596. We are having 80 and 84, we get 82 as the midpoint. Then times 10, 820, like that. So we're supposed to know that to get min, we need the summation of f of x divided by summation of f. So we add up f times x, 172.5 plus 294 plus 594 plus 186. I'm adding 596. Then I add 820. I'm getting 2662.5 out of 45. Total frequency is 45. Yeah, the total frequency is 45. So we divide this by 45 now. The mean shall be 59.17. 59.17 is our mean. 59.17, that is our mean. A good question. Very, very good question. A very good question. Can we check together now? Part C. In part C, we're being told to draw histogram to represent the above data. Draw histogram to represent the data. Now, I want you to study the histogram well, the data well, and you shall be realizing that the class intervals are not the same. From 30 to 39 is not the same as 40 to 44. From 45 to 54 is not the same as 55 to 69. So the intervals are different. When class intervals are different, we usually plot frequency density against what we call class boundaries. So how do we get frequency density? Frequency density is given by frequency out of class length. So we need now to come up with another row whereby for every class we're supposed to compute frequency density using a frequency over class width. Frequency over class width. Every frequency over class width. This one we've already done. So allow me clear up this space so that you may establish something else now. And that is FD, frequency densities, whereby we need frequency over width. 5 divided by the width here shall be 39.5 divided by 29.5, or minus, sorry. So the width here is 10. So 5 over 10. 5 over 10, we get 0.5. The next should be 7 divided by, the width is 5. From 40 to 44, the width is 5. 7 over 5, so 1.4. The next is a frequency of 12 divided by the width here, 54.5 upper boundary minus 44.5. It's a 10. So 12 divided by 10. 12 divided by 10, we get 1.2. 3 divided by 69.5, the upper boundary, minus 45 of 40. I'm using 69.5 and 54.5. 15 is the width. So 3 over 15, 0.2. 0.2. The next is, the interval is 10. The interval is 10. So 8 over 10, because it's frequency over width. 8 over 10, 0.8. The next one is, interval is 5. So 10 over 5, we get exactly 2. 10 over 5 is exactly 2. Exactly 2, like that. So now we can now plot frequency density against boundaries. We can start with frequency density. Allow me to use intervals of 0.2, 0.2, 0.2, 0.4, 0.6, 0.8, 1.0, 1.2, 1.4, 1.6, 1.8, and 2.0. So we have the frequency densities together with their scale, properly chosen scale. Now on the other axis, you can see the smallest class. The smallest class boundary is 29.5. So we can have it now on the starting of the axis, 29.5 here. 29.5 can be here. 29.5 can be the starting there. So that we add 10, we get 39.5, 49.5, 50.5, 60.5, 70.5, 80.5. 80.5. Yeah, I think it's a 5.5 will also be accommodated there. So those are the intervals. Now with that, we can check the first class. The height will be 0.5, that is the frequency density, and the class is running from 30 to 39.5. Height 0.5. Height 0.5. 0.5 is exactly between 0.4 and 0.6. Exactly in between, like that. You see, that is the first bar. Then we proceed. The next should be up to 44.5. height 1.4, 44.5, height 1.4, up to this point, up to that point. The next supposed to be height 1.2 up to 54.5, up to 50. Yeah, 54.5 up to 54 point. And actually the other one was 44.5, not 45. 44.5. The other one is up to 54.5. And height is 1.2. Height 1.2, like that. So the height is maintained there. Now from 54.5 all the way to 69.5. 69.5. So 69.5 is just before 70.5, and height is 0.2. Height 0.2. The height is 0.2. That way. From 69.5 all the way to 79.5, height 0.8. Up to 79.5, height 0.8. So 0.8 is there. Like that. Good one. Good one. I think request of more paper 2 mathematics. Okay, we have done enough of them in this platform. I don't think anyone here can finish going through all the prediction papers that we have been posting on the platform. Nobody can finish going through them. So at any given time, you have either paper 1 or paper 2 to revise with. So kindly peruse. And these predictive mocks are very good for every year. So height 2.0 all the way to 84.5. 2.0 all the way to 84.5. Like that. See? So we have now the bars. We have the bars properly plotted. It's good for you to know that the bars are usually in contact. They are supposed to be in contact. Just as you can see, they are supposed to be in contact. Even this one is supposed to show that it is starting from this point, like that. So we have the bars well drawn, well drawn. Look at the second part now, the part which makes the learners think that the concept is difficult. That is part D of this. In part D, we told using the histogram in B above, determine the median mark. Determine the median mark. Now, median mark, it's good for you to know that area of these bars represent frequency. Area represents frequency. And now we need 45 over 2. 45 over 2 gives us what? 22.5. That is now the position which contains the median. 22.5. That is what contains the median value. So we want to check area until we accommodate area equal to 22.5. The heights are fixed. The heights are fixed. So at this point, we can talk about the first area. The first area, which is 5. The next one, which is 7. 5, because we are taking 0.5 times the width. 0.5 times the width of 10, we get 5. The next one is equal to 7. That is 1.4 times 1.4 times 5 again. So how much area is that? 5 people in the first class, plus we get 7. 7 plus 5, we get 2. So we have 2 students in the first 2 classes. Now in the third class, how many people are there in the third class? They are 12. 12 plus 12 will give us 24. So we shall be beyond. So we need up to 22.5, and we have 5 and 7, that is 12. So remaining shall be, when we take 22.5 and we subtract 12, we shall get 10.5. Is that true? 10.5. So we need 10.5 more. If in the third class, the height is fixed 1.2, height of 1.2 times a known width, so that we may get 10.5. So width is going to be, we divide by 1.2, and I'm getting 8.75. 8.75. Therefore, from this limit, the limit of the second class, which is 44.5. So from 44.5 here, 44.5, from 44.5, we are adding 8.75, so that we get the mark which aligns with the 22nd.5 students. So we add this one. So we are adding a 8.75 with 44.5. This shall exactly be 53.25. You can even use the formula of finding median, and you confirm. You will find that the median is exactly the same value. Exactly the same value. So that was the simple question on statistics. We can check number 21. In number 21, you will allow me to refer to the original. I think there are some values that are not well fitted there. Some values are not well fitted there. Let me extract the values. Given that we have 2 vectors here, not vectors but matrices. Matrix A equals to, let me check, 3x, then x plus 1, and B equals to 1, 2, 3, 0. 1, 2, 3, 0. Yeah. Find the values of x for which, I think that's okay now. Find the values of x for which AB is a singular matrix. AB means the product. AB means the product of A times B. AB means the product of A times B, the product of A times B. So we can check the multiplication of the 2 matrices first. Multiplication. Wow, 4 Central, Ngoto represented. Thank you so much, Ngoto. Thank you so much, Ngoto Boys. That is one of my former schools. I ever worked at Ngoto Boys in Makueni County, Nzawi Sub-County. Say hi to Ngoto Boys. Say hi to the other Ngotorians. Otherwise, thank you so much for following us. So we're talking of product of A by C, A by B, 3x, x plus 1 multiplied by 1, 2. Let's get the product first. 1, 2, 3, 0. Can we get the product first? We get the product first. Row times column, meaning that 3 by 1 and x by 3. 3 times 1 is 3 and x by 3, 3x. So 3 plus 3x is the element at that point. We proceed with multiplication. Row times the next column, 3 by 2 and x by 0. We get 6. X by 0 just becomes a 0. That's all. And are you sharing with your friends, you guys? Are you sharing? Are you sharing with your friends? Thank you. Thank you. The next row and the same columns, x plus 1 times 1 and 2 by 3. So that will be x plus 1 remaining the way it is because you're multiplying by 1. Then 2 by 3, we get 6. So x plus 1 plus 6. We get x plus 7, like that. And finally, x plus 1 by 2 and 2 by 0. X plus 1 by 2 becomes 2x plus 2. You see? So we have the product of the two matrices. Now, the instruction here is that this product equals to a singular matrix. A singular matrix is a matrix without inverse. If a matrix has no inverse, it means it has a determinant of 0. A determinant of 0. Now, how do we get determinant of a matrix? Product of elements in the main diagonal minus product of the elements in the other diagonal. This way, if your matrix A, B, C, D, then determinant shall be given by product of elements in the other diagonal in the main, that is A times D, minus C by B, C times B. That gives us what we call determinant. So product of the elements in the main diagonal is a 3 plus a 3x into 2x plus 2 minus 6 multiplied by x plus 7. Now we're being told that this is supposed to be a 0. Thank you from Kiambu. Thank you, our followers from Kiambu. You can invite your friends to this particular presentation. All right. So can we expand? Can we open brackets? Can we open brackets? 3 multiplied by everything in the second bracket. That becomes 6x plus 6. Then 3x multiplied again by everything. This becomes 6x squared plus 6x minus 6x minus 42 equals to 0. We can group terms together. Grouping terms together means, look at this, 6x minus 6x, that one cancels out. This is a 6x squared. Then when it gets to x, we are only having 6x. Then now we are having 6 and a negative 42. 6 minus 42, that becomes negative 36 equals to 0. I hope those terms have properly been grouped together. Please check and confirm. Check and confirm. All right. So we can divide by 6. We can divide by 6 like that. You see? So it's a quadratic equation. And that's why the examiner is talking about possible values, meaning that we shall get more than one value. I was already suspecting this quadratic because of this. Product A times C, negative 6. Sum, positive 1. Two factors. Their product, negative 6, but their sum is 1. Is it 3 and negative 2? Multiplied, negative 6. Added, positive 1. So we rewrite our equation. X squared, instead of plus x, we have 3x and negative 2x. which is just x minus 6 equals to 0. So we are replacing the x with 3 and negative 2. You get that? Then from the first two, we factor out x, we remain with x plus 3. We factor out negative 2, x again plus 3. This is equal to 0. With this, we can talk about whatever is inside the brackets, then whatever is outside x minus 2. This is equal to 0. X plus 3 equals to 0. You know, each of the factors can be equal to 0. So when x plus 3 equals to 0, negative 3. X minus 2 equals to 0. So x equals to positive 2. So the two possible values of x are negative 3 and positive 2. Negative 3, positive 2. A very good question. Very, very good questions. Very, very good question. Are we together there in multiplication of matrices and also discovering what a singular matrix is? A matrix without inverse, meaning that it has a determinant equivalent to 0. A determinant equivalent to 0. A very good question. Very, very good question. If you're learning something, type yes, I'm learning. Yes, I'm learning. Yes, I'm learning. As we check the second part of the same question together. As we check the second part of the question together. Part B of number 21. We are moving. I've told you we are finishing this section. So do not relent. Stay tuned. Stay tuned until the end of this paper. Jane in part B. What is Jane doing? Thank you so much. Highway, thank you. Now, Jen bought 3 exercise books and 5 pens for a total of 165. Jane had bought 2 exercise books and 4 pens. He would have spent 45 less. Okay? Taking X to represent the price of an exercise book and Y to represent the price of a pen. Form 2 simplified equations to represent the above information. To represent the above information. At what time does the lesson start? But the lesson has already started. What is wrong? You want to get back to the beginning of the lesson? You can still check. Again, it's good for you to know this, that whether you attend the live presentation or not, this particular lesson will still be preserved here and you can follow at a different time. Hello, Teacher Katum. All right, thank you so much. Some people know my name here. Wanchiro from Mukia Girls and Kirigo. Asante. Thank you for following up. Thank you for following up. Okay, form 2 equations and we simplify them, of course. So 3 exercise books and each exercise book is going for X plus 5 pens. Each pen is being sold at Y. This equals to 165. That is one linear equation. Again, we're being told that Jen had bought 2 exercise books, 2 each at X and 4 pens each at Y. He would have spent 45 less. 165 less 45. He would have spent 120. Somebody is watching from Kisumu. Let me tell you, we are converging the whole Kenya here. You better join Shifting Grades. Please advise your friends to also join us. We are learning a lot. Look at this. We are already having the equations here. Allow me say that they are already simplified. Though equation 2 can still be further simplified, but we can use it at that point. Now, this is a linear equation. We can form what we call matrix equation. A matrix equation will be formed by taking the coefficients first. 3, 5, then 2, 4. This is called the coefficients matrix. Thank you from Githurai. Then after that, we go to variables. X, Y are the variables. Equals to 165 and 120. These are called the constants matrix. So we have coefficients matrix, variables matrix, and constants matrix. Those are the names of the matrices. Though you don't have to name them. We've said this is constants matrix. Constants matrix. This is variables matrix. Variables matrix. And this one is the coefficients. Coefficients. Yeah, coefficients. The matrices like that. So we have a matrix equation and linear equations. Use the matrix method to find the price of a exercise book and that of a pen. We solve for X and Y in other words. So we are supposed to find the inverse of the coefficients matrix. Inverse of coefficients matrix. Inverse of the coefficients matrix. We start by the determinant. What is the date? Product of elements in the main diagonal, 3 by 4, minus product of elements in the other diagonal, 5 by 2. This is 12 minus 10. 12 minus 10 is 2. 12 minus 10. Muyeje School in Malindi, Asante. 12 and 10, we get 2. We have the determinant. So we are supposed to divide every element by the determinant. Look at that. We divide every element by the determinant. But for the elements in the main diagonal, we are supposed to exchange their positions. For example, 4 takes that position and 3 comes down here. Then for elements in the other diagonal, we change their signs. This becomes a -2 as this become a -5. Then now each is supposed to be divided by 2. So we multiply by half. Multiply by half. This is now going to be 2, -2.5, -1, then 1.5. So now we have the inverse properly worked out. Now with the inverse like that, we pre-multiply now the matrix equation by the what if they are already negative? I've said you reverse the sign. If they are negatives, they become positive. Now that they were positive, they became negative. Thank you. All right. So now we pre-multiply 2, -2.5, -1, 1.5. Then now we multiplying 3, 5, 2, 4. This is xy equals to, we start with the meaning of pre-multiplication. We start with these. When you order them differently, they will not be compatible for multiplication. They will not be compatible for multiplication like that. You see now? That is pre-multiplication. At that stage, at such a stage, ladies and gentlemen, I don't want you to strain so much. I don't want to make you strain so much. This is a matrix multiplied by its own inverse. A matrix times its own inverse, we get the identity matrix. A matrix times its own inverse, we get the identity matrix. It's like multiplying a number and its reciprocal. You get 1. So we get identity matrix. Identity matrix equals to 1, 0, 0, 1. Then multiplied by xy. So I mean, this matrix times its own inverse equals to identity matrix. You don't even have to perform the multiplication. You are supposed to know that a matrix times its own inverse gives us the identity matrix. This now equals to, the other side now we multiply row times column, 2 into 165. Negative 2.5 into 120. This gives me 30. Then for the other side, the next row and the same column, negative 1 into 165 plus 1.5 into 120. I'm getting exactly 15. When we multiply the identity matrix times any matrix, the matrix remains unchanged. This remains unchanged, 30, 15, meaning that the value of x equals to 30, the value of y equals to 15. So we are now having the price of an exercise book and that of a pen. Exercise book equals to 30 Kenya shillings. A pen, this particular shop, equals to 15 Kenya shillings. It is equal to 15 Kenya shillings, like that. A very good question. Using matrices to solve simultaneous equations. Using matrices to solve simultaneous equations. Are we together? Are we together, ladies and gentlemen? If yes, type yes. We are together. Remember to join our programs. And actually, if you're a candidate and you are a scholar, during term 3, we have very serious mentorship programs. You can use our number to get more information about the same. As we continue learning, please chat our WhatsApp so that you may get more details about our programs. For the continuing students, during the November-December holiday, we have serious classes, and we invite all of you to join our interactive classes, which are usually via Google Meet. So please do not be left out. Number 22, the figure below shows a triangle ABC enclosed in a circle. AC equals to 7.5, as you can see. AC 7.5. BC 7.1, sorry. Okay, 7.1. All right. We can continue now reading together. AB 5. AB 5.2. We can see that 5.2, like that. Okay. So can we now read the question? Find the size of the ankle. Find the size of the ankle. A or 2, B. They mean A, the second center, B. This one, the second center is there. So this is 0, 2. This is 0, 1. Yeah, 0, 1. That is now what we are working on. Find the size of ankle, the ankle at that point. Now that from this circumference we have 3.6, and from this one we also, it's a radius, so it's supposed to be the same. We can now find the ankle at the center. Actually, we can use cosine rule. Just to show that we know mathematics, you can actually apply cosine rule. The ankle at that point. So that point, if the ankle is let to be beta, then we can say the opposite side, 5.2 squared equals to the other two sides, 3.6 squared plus the other one, 3.6 also squared, minus 2 into 3.6 and 3.6, the cosine of the unknown ankle. That's according to the cosine rule, trigonometry 2. We've all covered that. So now we can group some terms together. 5.2 squared, we subtract 3.6 squared minus again 3.6 squared. So I'm having 1.12. This is equal to 2 is being multiplied by 3.6 by 3.6 So I'm getting a negative at this point, 25.92, the cosine of theta, the cosine of theta. So to get the cosine of theta, we divide by negative 1.12, divide by the answer. I'm getting negative 0.04321. So if I'm to get the value of theta now, I need the cos inverse, shift cosine. One, getting a negative here means that the angle is greater than 90. It is in the second quadrant, most likely. So shift cosine of the answer here, and I will get 87 points. I'm getting 87 points. This is subject to review. Let me check. Shift cosine of negative 0.0 from 3 to 1. Yes, I'm getting 92 points. This is now the angle I wanted. That is now the angle, meaning that it's in the second quadrant. So you can use the cosine rule because we have all the sides. We have all the sides. Find the size of the angle. Find the size of the angle. ACB. ACB, the angle at this point. Can we use the same rule and call this one alpha? Then say 5.2 squared equals the other two sides, 7.5 squared plus 7.1 squared minus 2 into 7.5 and 7.1 cosine of that unknown angle. Cosine of the unknown angle. So we are applying cosine rule again for the triangle ABC. Yeah, for the triangle ABC. So we can get the angle alpha there. Taking 5.2 squared minus 7.5 squared minus 7.1 squared. This is negative 79.62. This is equivalent to, on the other side, we're having minus 2 multiplied by 7.5 times 7.1. We get negative 106.5, the cosine of angle alpha. So cos alpha will be equal to, we are dividing negative 79.62 divided by this value here, 0.7476, meaning that alpha will be the sine inverse, not the cosine inverse, that is, shift cosine. I'm getting 41.62 degrees to 2 dp. To 2 dp. That is now the angle at that point. Now that we have that angle, somebody from Maralal, thank you so much, Samburu. Thank you for following. That is cosine rule. I know the Form 4s are enjoying. I know the Form 3s covered this maybe the other day, and they might not be very well conversant with the same. But anyway, you will understand in the course of time. Concepts are instilled in your brain the more you practice them. When you learn cosine rule, sine rule, and you close your books, you will never understand. But when you meet them applied in Shifting Grades Online School, then you become a good student. Now check this in part C. Check part C. Find the radius of the circle center 1. Radius of the circle center 1 to 1 dp. The radius of this circle is being found now, the radius here. This is what we are being told to find. The radius here. The radius there, that is what you're being told to find. Now, from Form 2 work, angle properties of circles. The chord AB is producing an angle at C of 41 points, meaning that the angle at the center, angle A, center 1B equals to, We multiply this angle by 2. Multiply it by 2. We are getting 80. Check 41.62 by 2. I'm getting 83.24. The angle at the center is 83.24. 83.24. So can we find that radius by saying this? We can subdivide such an area. We can divide the whole triangle into 2. Like that. Then we talk about half the area, which will again take us back to 41.62. 41.62. Then with the 5.6, 5.2, we can talk of 2.6. So now we have this nature of a triangle now. Let me bring it here. Let me extract the triangle. Extract it so that we may see what we are talking about. We are having a radius here unknown, but the angle here is 41.62. And here it's 2.6. This is now right angled. So how can we get this radius? We apply what we call trigonometry, sine rule. The sine of 41.62. The sine of 41.62. Sine 41. Sine equals to opposite length. So with the angle at that point, opposite will be 2.6. Opposite shall be 2.6 out of unknown radius, which is our hypotenuse now. Which is our hypotenuse. That is our hypotenuse. Confirm clarity. Both sound and the screen. Sound and screen. So R, we can multiply by R. So that to remain with R, we need 2.6 divided by the sine of, divided by sine 41.62. This is equal to 3.9 to 1 dp. 3.9. 3.9 to 1 dp. Exactly 3.9. 3.9. Exactly 3.9. Now, the other thing is that we calculate area of the shaded region. Area of the shaded region. When you look at the area of the shaded region, look at this. When you look at the area of the shaded region, I want to take you to the diagram. The shaded region is a combination of two segments. So there's a segment here due to this sector and circle. There's a segment here. To get the area of a segment, we need sector minus triangle. Sector minus triangle. So can we talk about segment 1 and segment 2? Segment 1 and segment 2. So the first sector, we can, let me split the two segments. Segment 1, segment 2. We start with segment 1. We need the first sector with this center 2. Center 2, and we subtract the triangle in that. Therefore, the angle at the center 2 is 92.46. So theta, 92.46. Is it 46 or 48? Out of 360. Theta over 360. Pi. Which pi have we been advised to use? No instructions about the pi. So we can use 22/7. A radius of 3.6 squared. Minus the triangle. So we need half multiplied by 3.6 times 3.6, the sine of the angle between 92.48, like that. So for the triangle, we shall be having for the sector, that is over 360 multiplied by 22 over 7 multiplied by 3.6 squared. I'm getting 10.46. 10.46. Minus half multiplied by 3.6. 3.6. The sine of 92.48. I'm getting 6.47. So now for the first segment, it shall be 10.46 minus 6.47. I'm getting 3.99 square centimeters. This is now segment 1. The first segment. What about the second segment? Now, the second segment is the one here now, having center 1, meaning that we need the sector. We know the angle at the center, of course. The angle at the center, the angle at the center, it's here. So 83.24 over 360 pi r 3.9, we calculated this, squared, then minus triangle half times 3.9 times 3.9 sine of the angle that way. So we can compute this sector first. 83.24 over 360 multiplied by 22 over 7 multiplied by 3.9 squared. This is giving us 11.05 minus the triangle inside this now. 0.5 times 3.9 squared sine of 83.24. I'm getting 7.55. This is equivalent to 11.05. When I subtract 7.55, I'm getting 3.5. So this is segment 2. Segment 2. Total shaded. It is now the two segments, 3.5 and 3.99 plus 3.99. This is 7.49 square centimeters. 7.49 square centimeters. So that is now area between two circles that are intersecting. Area between two intersecting circles. Area between two intersecting circles. Can we check number 23? Can we check number 23? Number 23. Now, the position vectors of P and Q with respect to the origin are -6, 5, 8, -5. With this information, we can also write the coordinates of P and Q. Now, the point M is the midpoint of PQ, and N is the midpoint of OP. Find part A, which has a Roman 1, the coordinates of N and M. Then part 2, the magnitude of NM to 2dP. Now check these. Ladies and gentlemen, check this one. I've told you that the coordinates of P can be interpreted from its position vector, and also Q can be given as 8, -5. Now, when we say that M is the mid of PQ, can we find M? Midpoint is given by the first X plus the second X, and we divide by 2. First Y, the second Y, we divide by 2. That is now the coordinates of the midpoint. So we need -6 and 8 over 2, 5 and -5 over 2. So this midpoint shall be given by negative 6 plus 8, we get 2. 2 over 2, we get 1. Negative 5 minus 5, we get a 0. Over 2, it remains a 0. So the position vector of M is 1, 1, 0. What about N? N is the midpoint of OP. OP means O is the origin, and P is here. So midpoint means 0 and negative 6, we divide by 2. 0 and 5, we divide by 2, like that. So N will have coordinates negative 3 and 2.5. Those are the coordinates of point N. Those are the coordinates of point N. Yeah, the coordinates of point N, like that. With N and M, we can proceed to Roman 2. Now, Roman 2, the question is telling us to find the magnitude of NM. NM, you have to find the vector first. M minus N. M is 1, 0. N is what we are getting here, negative 3, 2.5. All right, this is 4 because of 1 minus a negative 3. Then this is negative 2.5. 2.5. So we have now the vectors. We have the vector NM. You see that? You see that? So now we can find the magnitude. Magnitude is the length of the vector. I hope we can see clearly. Confirm clarity of the screen. From my other gadget, I can see the screen is very clear, very, very clear. Actually, no interruptions today. No hiccups today. Everything is quite clear, quite clear. So we need the magnitude now of NM. The magnitude of NM, 2.5. Okay, negative, also squared. Then now we'll be taking the square root of everything. We've been taught to 2dp. So 16 plus 2.5 squared, and we take square root. I'm getting exactly 4.716. 4.716, making it 4.72 units. 4.72 units. So that is now, we are following instructions here. 2dp. Part B. Now point A is mapped onto. Look at this. Point A is mapped onto A prime by a translation vector negative 5, 6. Given that vector OA equals to OP plus 2 vector NM or MN, find the coordinates of A. Can we find the position of A first? Equals to OP. OP was what? OP was negative 6, 5 plus 2 multiplied by which vector? MN. Vector MN. So can we find vector MN first? MN means N minus M. N is here. And M is 1, 0. So we talk of negative 4 and 2.5. So this is what we are multiplying by, to negative 4 and 2.5. Negative 4 and 2.5. So vector OA equals to what? Equals to negative 6, 5. This is negative 8. This is 5. So now we can talk about negative 14 and 10. This is now vector OA. Vector OA has been found. After finding vector OA, Ladies and gentlemen, now that you have vector OA, we can say that vector A is known, point A is known. So we say this, translation vector from plus a coordinate gives us image. Translation vector plus a coordinate gives us image. So the translation vector, which is negative 5, 6, plus position of A, negative 14, 10, we are supposed to get an image. Negative 5 plus a negative 14, get negative 19. 6 plus 10, we get 16. Therefore, this is the position of the image of A. Therefore, meaning that to write it as a coordinate, it should be negative 19, 16. When you write it now as a coordinate, negative 19, 16. Negative 19, 16. Negative 19, 16. A good question. Very, very good question. We can now check the last question, the very last, ladies and gentlemen. The very last. So we are looking at the question number 24. Remember, I told you when you follow up, you discover that all the course that we get started, all the questions are simple. They are all doable. All of them are doable. Now, the displacement of a particle x meters, t seconds after passing a fixed point O is given by x equals to 3 plus 2t. Let me write actually the expression now, the equation afresh. 3 plus 2t minus 5t squared minus 5t squared. So we are having our expression. We are having our expression for the displacement. Displacement is distance. It's good for you to know that. Displacement is distance. Now we can proceed. I've made the correction, so we can proceed. We may proceed. We may proceed. Okay. Calculate part A. Calculate part A. Trying to get back to the live so that I may see what is happening. Thank you, teacher. Enjoying the lesson. Oh, thank you. Thank you. Thank you. Now we work out this. Now we are told in part A that the displacement, we work out the displacement of the particle after 2 seconds. You know, we are already given the displacement function. So working out the displacement, which is x, shall be 3 plus 2 into 2 minus 5 into 2 squared. So this is 3 plus 4 minus 20. We get negative 13 meters. Negative 13 meters. When you get negative and you're working out with the vector quantities, it's an issue of direction. You know, it doesn't mean that we have a distance which is less than 0. Whenever you get a question, it means it's just distance in the opposite direction. Time taken for the particle to return to 0. Time taken for the particle to return to 0. In other words, when the particle has returned to the origin, when the particle returns to origin, if you move from a point, and this is a physics language, when you move from a point and you get back to the same point, according to linear motion, we say that the displacement that you've covered is 0. If you move until you get back to where you are, even if you've covered 1,000 kilometers, even if you've moved for 1,000,000 miles, the displacement is 0 because at the end of the day, you are where you were. Therefore, we need the time taken for this displacement to become 0. So 0 equals to 3 plus 2t minus 5t squared. So we can have 5t becoming positive on this side, 2t becoming negative, but 3 becoming negative, like that. So we have a quadratic equation. whereby we are supposed now to solve and get the values of t when displacement becomes 0. That is when it moves until it gets back to where it started, until it returns to O. So that interpretation now is very serious. Now we solve. We can now solve. Product, can we talk of A by C? Negative 15. Sum, we talk about the value of B, which is negative to 2 factors. Is it negative 5 and 3? Yeah, negative 5 and 3. Products, negative 15, sum, negative 2. So 5t squared minus 5t plus 3t, then minus 3. Minus 3 equals to 0. From the first two 5t, we remain with t minus 1, then plus 3. We remain with t minus 1. T minus 1 equals to 0. T minus 1, 5t plus 3 equals to 0. So t equals to 1, and also 5t equals to negative 3. So t equals to negative 3 over 5. Now that time is a measurable quantity, it cannot be a negative value. So we talk about time being 1 second. 1 second. It takes 1 second for the displacement to become 0, or 1 second for the particle to return to where it started, to point O, returning to point O. That is the meaning of returning to point O. Then part C of the same question, guys. Now in part C, we read part C. Part C, we told to find the maximum displacement of the particle. At maximum displacement, we say velocity equals to 0. By the time a particle reaches maximum height, it means there it's having a velocity of 0. So that after maximum now it starts coming down. So velocity is 0. How do we get velocity function? We differentiate displacement with respect to time. Can we differentiate the function that we have? When we differentiate this, the constant will disappear and 2 remains alone. We shall have 2 minus. We are now having negative 5t squared. The power 2 drops here. We have negative 5 times 2, negative 10. Then now t at such a point. T will be there. You see? T will be there. Now we have the velocity function. So maximum displacement means when velocity is 0. So what time will be velocity 0? We equate to 0 so that we may get the value of time. The value of time when velocity will be 0. What will be the value of time when velocity shall be 0? What will be the value of time when velocity will be equal to 0? Are we together there? Then the value of t shall be 2 over 10, which is 1 over 5. 2 over 10 is 1 over 5. 1 over 5 like that. 2 over 10 is 1 over 5. So now we're talking about maximum displacement. Maximum displacement means now displacement at this particular time. Displacement at this particular time. So substituting in the displacement function, it will be 3 5 into t squared into t squared. Yeah, it's into t squared. Confirm clarity, confirm whether you can hear us well. Okay. Thank you. Thank you. I'm reading your comments, Goto boys. Thank you so much. Now we can compute these. You see, 1/5 is exactly 0.2. So 3 plus 2 into 0.2 minus 5 into 0.2 squared. This is going to give us 3.2. 3.2 meters. 3.2 meters. So we wanted the displacement, a maximum displacement. For maximum displacement to be covered, velocity has to become 0. So we had to find the velocity function. Thank you for those who are confirming that the screen and the sound is clear. We are almost winding up, ladies and gentlemen. We are almost winding up. Look at part D of this. In part D, we're being told to find the initial velocity. Initial velocity means velocity at t equals to 0. That is the initial velocity. When the particle is just starting. Initial velocity. So velocity function is here. So initial velocity shall be 2 minus 10 into 0. So we get 2 meters per second. 2 meters per second is our initial velocity. Then together, thank you. This guy is a legend. He saved me back in high school. Still a legend. I'm also still subscribed because of that. Thank you so much. Thank you so much for recognizing our good work. We request you to continue referring people to a platform like this one so that you may continue helping other people. Can we check part E of this question? In part E, we're being told to find the acceleration of the particle after t seconds. Now, acceleration is given when we differentiate velocity with respect to time. So velocity function is here. So we differentiate this. Differentiating this will be 2 is a constant. So the constant will disappear. Now t is to power negative, t is to power 1. So negative 10 times 1, it becomes negative 10. And the 10 will disappear. So acceleration after t seconds is negative 10 meters per second squared. You just differentiate velocity function and we are getting a constant. So that's how we were supposed to handle such a paper. The section B, the section 2 of the paper. Section 1 was earlier done. You can review in our platform. Thank you so much. We shall continue meeting in this platform to ensure that you people are well equipped for KCSE. See you in another presentation. For the continuing students, you can consult our number 0704 15 33 66. We are having November, December holiday classes, and we invite everybody to our classes. Thank you so much. Bye-bye. Good night. See you another time.